All right, so this lesson's section 4.3. So the start of proving triangles are congruent. So to prove triangles are congruent, we need to show that all the corresponding parts are congruent, all the angles are congruent. Or do we? Do I need to show all 6 parts congruent? Or can I do it with less? What is the minimum amount that I need? Well, over the next 3 sections, we're going to look at a series of situations and what is required to show that 2 triangles are indeed congruent. So here's the first one. The first one is called side angle side. So if I have basically 3 pieces of information, namely 2 sides and the included angle, if they are congruent from one triangle to the next, then I know that both triangles and all the parts of each triangle are indeed congruent, and I can say that the triangles are congruent. So side, angle, side. So 2 sides are congruent to 2 sides of another triangle, and the included angle, that means the angle between the formed by the 2 sides, is congruent to the same one in the other one, then these 2 triangles will be congruent. Another one we're going to look at in this lesson is the side, side, side. Well, what if I don't have any angles? I don't know any angles, but I do know that all 3 sides are congruent to the 3 sides of another triangle. Okay? If that occurs, then the 2 triangles are said to be congruent again. So we have side, angle, side, and side, side, side. Okay? And so what we're going to be doing to show the triangles are congruent is try and find these pieces of information that allows me to do one of these 2 rules to show triangles are congruent. And so all of our examples are going to be part of that. Once I have triangles congruent, okay, once I know that triangles are congruent by these things right here, see, then I have what is called all the parts are congruent. Okay, once triangles are congruent, all the corresponding parts are congruent, and that's this thing right here. Corresponding parts of congruent triangles are congruent, and we abbreviate it with CPCTC. So this will be more reason when we start doing some proofs and stuff. So if I have 2 triangles are congruent, then all the corresponding parts are congruent. And so we already talked about this on the naming aspect of how things work. Based off the naming of the 2 triangles, you can tell which parts are corresponding and which are congruent. Okay? So let's go ahead and dive into some of these things and see what we get. So here's an example. Let me go ahead and pull it over here so you can see it. We can work on it together. So it is a proof that we're going to show that angle B is congruent to angle D by looking at this and given this information up top. Now, the given information I've already marked in our picture. AB and CD are parallel. That's what these marks here mean. It means they are parallel. And AB and CD are congruent. Okay? And so I need to show that this angle and this angle are congruent. Well, if I can show these 2 triangles are congruent, okay, if I can show these 2 triangles are congruent, then by corresponding parts, I can say that B and D would be congruent, and that's our game plan. Okay, so we use all of our knowledge that we've learned from before, and we base everything off of just have parallel lines. That means we're going to go back into the parallel lines aspect for congruent angles, and look what we have right here. So let's walk through it, and then we'll write it out. Since this line and this line are parallel, and this is a line that cuts them both lines, then I have alternate interior angles will be congruent. So I can say that this angle is congruent to this angle because these lines are parallel and alternate interior angles will be congruent. Then if I look at this triangle right here, I'll have this piece, I'll have this angle. Then I either need to have, since I have an angle, I'm probably going to see, can I get another side? Well, in both triangles, they share this side. Since this is a shared side, obviously, it has to be congruent to itself. So I can say that this side is congruent in both of the triangles. And what I have then is displayed that I'm going to have a side angle side relationship. Side angle side relationship. And so the two triangles will indeed be congruent. So that's what we're going to be using. So let's go and use that. So how do I write this out? Again, we're not doing any rigorous proof. We're just kind of like talking about what we know and why we know it. Okay? Let's start with the angle since the lines are parallel. So because AB is parallel to CD, okay, then what can I say? Now, then I can say, now when we name these things, we got to name them in the same order that we choose, okay? So if I'm going to go B to A to C, B, A, C, then I have to do this in the same, name the second one in the same way. See how I went from B to the angle? Then I have to go from D to the angle, like that. So this one has to be named DCA. So the way you name it matters also. We also know because B and D are going to be congruent, they have to be labeled in the same position. Okay? All right, so I know that. Why do I know that? Because if the lines are parallel, I know that alternate interior angles are congruent. And you can abbreviate like I just did. What else do I know? Well, I need this other side. Okay, so again, the way we name it is also important. I can say that AC, so in this triangle, A to C, see I'm starting at the angle here in between, A to C is going to be congruent. I can't say A to C again because this is how we started at the angle, we got to start at the angle. So this one is read C to A, C to A. Why? Because they're the same side. Now your textbook will have a different name for this. They call it the reflexive property. It doesn't just say they're the same side. So now what do I have? I have a side, an angle, and a side. So I can now conclude that triangle ABC will be congruent to triangle. Now watch the naming. A and C are congruent pieces, B and D, okay? And then, so when we name these things, you have to name it properly so that they match. So this would be C, D, A. Why? By side, angle, side, theorem. So now that I have the triangles congruent, then I can come and answer the part up here, why are these congruent? So angle B is congruent to angle D by corresponding parts of congruent triangles are congruent. And that is all you need to say for me. Okay? Another thing you're going to be asked to do, and it's all part of the same thing, is this question right here. You need to be able to look at stuff, see the information that is given to you, and determine if triangles are going to be congruent or not. You may or may not need to prove it, but you should always explain why. Why is very important here. Are these triangles going to be congruent? Well, they have one side congruent, they have another side congruent, and I have what? I have either side, angle, side. So can I show that an angle is congruent? Or can I show another side is congruent? Well, if you look closely at it, you'll see that they share that side right there. So I would say that yes, we can. By what? By side, side, side. LM is congruent to NP. LM NP. See how I went from this little angle to this angle here, the bigger one? Then I went from the little angle to the bigger angle here. Same position, same order. MN is congruent to MNPL. Could I have named it different? Could I have gone LP? Sure. If I went LP, then I needed to name this one NN. They just have to be, corresponding pieces have to be lined up so we know how it works. And then this one, LN, will be congruent to NL because they are the same side. So are the triangles congruent? Yes. Triangle LMN is going to be congruent to triangle NPL by side, side, side. So you're just listing all the things that you have. This is a side, this is a side, this is a side, 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 side. That's how you tell. Okay? And this is how you kind of label and write off your work. Okay? So that's the first of our series on proving triangles congruent, and we'll do some more problems together in class.